what are some of its parts? Can you tell me some of its parts?
The XY axis.
Okay. So the coordinate plane has an X and a Y axis. Which one's horizontal? X, right. So X is horizontal, and the vertical one must be the Y. Y to the sky, right? All right. Sometimes people get mixed up, especially in high stress situations like tests. We get confused, turned around, disoriented, whatever.
What are we saying here?
Y to the sky.
X minus Y minus.
No, the X and the Y axis.
Okay.
It's a hyphenated word. Thank you. What else is on the coordinate plane? What do we call the spot where they intersect? What? Where the axes intersect. Yeah, the origin. So we have an origin. That's where the x-axis and y-axis intersect. Okay. What else? Anything else? How is it broken into parts? Is everybody done with this stuff up here? What? Said that. Yes, quadrants. So how many quadrants must we have then?
4.
4. We've got 4 quadrants. Where do they start? Now we start where it's all positive, right? Then we end up where it's all negative. I don't know if that's some sort of allegory or what. Yeah, 1, 2, 3, and 4. All positives, positive negatives, all the way around. Good. So we know what it is. We know what it looks like. We know basically its parts. We know that the coordinates in this quadrant are all positive, right? Positive, positive. I'm going to have to change my pencil. So in this quadrant, we're positive, positive, right? What are we in this quadrant?
Negative positive.
Negative, positive, yep. This quadrant, negative, negative. And this quadrant, yeah, and so the coordinate plane gives us basically like little addresses for the points, right, for the solutions. So each solution has the x value. What's the x value, the input or the output? Input is x, output is y. So when we put those points on there, the x and the y gives us the address where that point goes. All right, okay? And we know the first element of an ordered pair. What does an ordered pair look like? X and Y, yep. So that's our input that matches that output. If I put that into the equation, that's what comes out, right? Or into the function, that's what comes out. So that's our input, that's our output. Sometimes you'll see y represented as f of x, or g of x, or h of x. That just means the function in terms of x, but that's your y coordinate too. Right? I don't know if y'all use that notation a lot already. Okay, good. Yeah, you should be comfortable with that notation. We'll use it a lot. All right, any questions? Y'all good? Okay. All right. So let's label some points. Can I put a new slide up here? Okay. All right, so if I have, let's see, I wonder if this will make a straight line for me. So let's say that this is my plane, okay? And so I want to graph some points. I want to put point A at -3, -2. Where do I go? Back 3, down 2, right? 1, 2, 3, 1, 2, so they're right here. That's point A, right? Okay. Point B at -2, 2. Where do I go? Back 2, up 2. So 1, 2, 1, 2. There's point B. Okay. Hmm? Sometimes it's a big O. What?
How's the symbol work?
Just a big O. Usually. Sometimes you'll see a point, and you'll say you have an O there. There may be other notations. It probably just depends on what text you're using. Okay, what about C? 1, 3. Where does it go? That way? Positive? Up 3. 1, 2, 3. Point C. Okay. Point D. 2, 3, 4. Not 2, down 4. 1, 2, 1, 2, 3, 4. Okay. And then point E at stay on the axis, right? All right, good. So basically, all the points will have will live in a quadrant, except for the ones that are on the axes. Okay, so like point E, it's not in any quadrant; it's on the axis. Okay, so it's on the x-axis. But point C is in which quadrant? 1. Point A is in which quadrant?
3,
Point D
4,
and point B.
2.
Good. Right. So y'all are comfortable with that, right? You're good. All right. So we don't always just graph points, though, right? Are y'all comfortable with graphing regions on the quarter plane? Is that news? Okay. So this is graphing points. And then let's do another graphing and describing. Sometimes you'll have a question that says describe the region. And a lot of times they'll be written in set notation. You've seen set notation. That's what we use our domain in. So you may have a question that says describe and sketch the region given by each set. All right. So the first one, we're going to have x such that x is greater than or equal to 0. So in your mind, what does that mean? Where is x greater than or equal to 0? Where? It's so if I put my coordinate, if I have a grid, where would I shade? Would I shade quadrant 1? Would I shade quadrant 4? Yes. Because even though y is negative, the x is still positive. What about the y-axis? Would it be included in this set, in the picture?
Yes.
Why?
Because x and e.
And equal to, absolutely. So yeah, good. We would shade that. So we would shade this, and we would shade everything over from it, right? That's what it looks like. And how would you describe that with words? How would you describe it?
Quadrant four shape.
Okay. So basically, it's all of the points. It's all of the points where x is either 0 or positive. And notice 0 is not positive or negative, it's in the middle, it's neutral. And they lie on the y-axis and
Right.
sorry about my handwriting here. All right. So that's how you would describe it with words, right? It's all the points where x is either 0 or positive and they lie on the y-axis or to the right of it. Or you could have said, like Tyler said, in quadrant 1 and 4. Every point is in quadrant 1 and 4. All right, what about this one where we've got x, y, such that y equals 1? What might that look like? So what are all the points? Where are all of the points where y equals 1? I hear two people saying stuff. Say it. Okay, a line for y is 1. Is that what you were going to say? Yeah. So it's going to be on this line here. One unit above the x-axis, right? All of those points are where y equals 1. Why are we not shading above or below or to the left or to the right of anything? Well, it's not 1 anywhere else, right? It's only 1 there. So how would we describe that with words? It's all of the points.
Where y is 1 is
Where do they lie? They're laid. All of the points where y equals 1 are, where do they live?
in the first and second quadrant.
They lie. Yeah, they're in the first and second quadrants. So we can say that. On, mercy's sake. On the line y equals 1. And nowhere else, right? Or they're 1 unit above the x-axis. Okay? All right, one more, and now I've got an activity for you all that you might enjoy. Okay? This is like old stuff, right? Just for refresher. Have y'all done the set notation stuff before with graphs? Okay. Yeah, it's not hard. The notation sometimes is the biggest obstacle, just the way it looks. Right? And that's the biggest problem. All right. Last one. Let's see. See if you can do this one. Well, maybe I'll just do it. So we've got x, y, such that negative 1 is less than y, which is less than 4. So what am I looking at here?
Y has to be between negative 1 and
Okay, y has to be between negative 1 and 1. So how do I make my boundaries if the boundary is not included? Dash. So where do I put a dash line? On y equals negative 1, right? So feeling like that's the same length because there's a slight difference there. So I'm going to have a dash line here. Right? Where else? On y equals 1, right? So I've got two dash lines. Where do I shade? Above them, below them, in between them? In between them. Feeling like that's consistently solid. All right, good. Easy enough? Good? Any questions? Okay. So tomorrow, how do y'all feel about the midpoint distance formula? Are you good with it?
what's the formula?
Square root of x1 plus x2 squared plus y.
Oh, yeah, I remember that.
Tomorrow you all have the ACT. Do y'all know a time frame for that, how they're doing it when they administrate?
It's usually like,
It's usually like 8 o'clock in the morning.
Yeah, I didn't know how they were gonna do it. Like,
I don't know,
They've not told us
anything.
anything. Mr. Dawson this morning, he gave us a packet for math that has Ms. Tab went through and answered all the questions, so if y'all want one, y'all should probably get in contact with him, because it's a very
It's a good
good paper. It is.
and I have made one of
You
those
should
that
go
Miss
through it.
Cooksey has too, if you need an extra set of problems.
We should have gone.
Only for math.
Yeah,
Or
it's for
the-
math.
Yeah, Miss Cooksey has it. I gave her my folder, and so she has it. It's got this. It's got a test from 2021, I think, in it, and all the solutions.
That's what this is.
I was looking through some of those problems on that packet, and I was like, how did I not know how to do this before? They look so.
Well, when you're stressed out, easy things get
It's
really
just a
hard.
question that gets me.
The way they word it.
You know, it's, I don't know what
I look at things like this is when it stresses
Yes.
me out. I'm
the
like,
shapes.
yeah, I like the shape. I'm like,
Okay, so I've got an activity for you guys. So you're going to be connecting the dots. So you've got ordered pairs. You've got one quadrant to work in, and you're going to connect this dot to that dot, and so on and so forth. Right? So don't just draw a whole bunch of dots and start connecting. You might want to connect as you go. So plot the following points in order and connect the dots. What do you see? So you'll come out with an image of something. It's not a cube.
I just thought it.
Huh?
I
Yep.
just thought it.
Plot is connected.
Did you say not to make the lines as we go, or do the lines as we go? go.
I would connect the dots as you go, otherwise you might get lost. There I am.